The topic of this video will be the Wolff-Kishner reduction of aldehydes and ketones. The Wolff-Kishner reduction is a two-step process. In the first step, the ketone or aldehyde is converted to an imine-like intermediate, called a hydrazone. This reaction is carried out by treating the ketone or aldehyde with hydrazine, along with a strong acid catalyst. The mechanism for the formation of the hydrazone is the same as the mechanism we've already discussed for imine formation under acidic conditions. In the next step, the hydrazone is reduced using strong base and heat. Just like the Clemmensen reduction, this produces the alkane, completely removing the oxygen from the original ketone or aldehyde. The other product of this reaction is nitrogen gas, which is the driving force for the favorability of this reaction. This reaction has the same outcome as the Clemmensen reduction, except that the Wolff-Kishner reduction is carried out under basic conditions instead of acidic conditions, as in the Clemmensen reduction. In other words, these two methods are complementary. The Wolff-Kishner reduction will only work in molecules that are not base-sensitive, whereas the Clemmensen reduction will only work in molecules that are not acid-sensitive. Now let's consider the mechanism for this reaction. Again, the first step is the same as the formation of an imine, so we will look at the step where the hydrazone is reduced to the alkane. Remember that this step is carried out under strongly basic conditions. Therefore, the first step will be deprotonation of the hydrazone. This produces an anion that is resonance stabilized. In the next step, the carbon that was the ketone or aldehyde carbon is protonated. The terminal nitrogen of the hydrazone is then deprotonated. This anion eliminates to produce nitrogen gas and another carbanion. In the final step, the carbanion is again protonated to produce the alkane product.